Electron Multiplying Charge Coupled Device, or EMCCD, has been the gold standard in scientific detection sensitivity in the field of microscopy since its pioneering introduction to the market by Andor technology in 2000. In 2005, we were the first company to offer a range of EMCCD cameras dedicated to spectroscopy. EMCCDs are the perfect solution for increasing demands for higher sensitivity and faster spectral rate. Single photon sensitivity can be achieved with an unrivaled combination of quantum efficiency, or QE, up to 95% and acquisition speed up to 1300 spectrum per second. When incoming photons reach a CCD detector, electrons are generated proportionally to the QE of the silicon bulk. For spectroscopic applications, electronic signal stored during the useful exposure time is then binned in the readout register, also known as the shift register. For conventional CCD structures, signal is directly shifted to readout electronics for spectrum graphical processing. For EMCCDs, electronic signals are shifted through an additional gain register where single photon events can be amplified well above readout noise by impact ionization of up to 1000 times. By doing so, EMCCDs overcome this noise source completely, thus dramatically improving the detection contrast of weak signals. When there is sufficient incoming signal to stay well clear of read noise floor, a high QE, deep-cooled, slow readout CCD delivers the highest signal to noise of all. ICCDs are shot noise and intensifier thermal noise limited, but offer superior nanosecond time resolution and better single photon counting. High QE, deep-cooled, optimized EMCCDs with moderate gain are however best suited for a low photon regime down to single photon counting. Newton EM cameras are the only spectroscopy-dedicated EM detectors on the market, bringing an unrivaled combination of high sensitivity, dynamic range, resolution and speed. Spectroscopy optimized Solus software and its associated software development kit, or SDK, are Andor platforms for the Shamrock series spectrographs and third-party system controls or integration. Having revolutionized low-light imaging, EM technology is now making an impact on low-light spectroscopy applications. The ultra-sensitivity it offers is pushing back the boundaries of traditional spectroscopic techniques and opening up a whole range of new application areas. Application areas where EM is being used now include photoluminescence, Raman, FRET, single molecule, transient and tunneling spectroscopies. Spectroscopy carried out on the microscopic scale, microspectroscopy, is where EM technology is having its greatest impact. Ultra-sensitive Forster resonance energy transfer, or FRET, spectroscopy is now being used in the development of immunoassays for screening of autoantibodies. This has the potential to become a key tool in the study of cancers and proteomics, particularly with a view to the development of early diagnostics. Scanning tunneling luminescence spectroscopy takes spectroscopy into the nanoscale regime where photon signals tend to be particularly low. It is used to characterize nanophotonic devices and their structures, to carry out single molecule optical spectroscopy, to study single molecule dynamic and conformational analysis, to measure intermolecular fluorescence, and carry out studies on electroluminescence. EM technology provides for significantly enhanced signal-to-noise measurements when compared with the conventional CCD. The benefits of EM technology is only fully realized when having to work in a low-light regime. Low signals may be due to a very small sample size on a microscopic scale, or indeed down to the single molecule level, or the desire to use the lowest excitation power possible to prolong sample lifetime, or to achieve the highest spectral rates of acquisition possible so as to enable good temporal resolution on dynamic processes. Whatever the reason, if your experiment is struggling with a low photon signal, then why not consider the use of EM technology and the sensitivity it can provide. The Newton EM camera from Andor is the most powerful and versatile CCD spectroscopy camera in the world. Visit Andor.com or EMCCD.com and discover new ways of seeing.